Nanga. Are we good? Can I good? Are you sir? Well, are we together? All right. All right, ladies and gentlemen, my name is Odwak Nanga, and I am attempting to break the Guinness World Record as the longest mathematics lesson, that is MC Calculus Math-A-Thon, and my reference number is 230 6161 31731 LML. And I am right here in King's Key Christian Schools. By my side here, I have some officials. For this purpose, I'd like to introduce them. I see here Mr. Victor Nya, a professional football referee from Nigerian Referee Association, and Mr. Kani Udoite, also a professional referee. The two will act as timekeepers as well as independent observers. Also have two stewards who will screen the students and also disqualify them. And we are going to also have another two set that will be shifting. And so I love to give them some minutes to introduce themselves.
Good evening, everybody. Victor Nya is my name, and I will be serving as the timekeeper throughout this record attempt. I am a member of the Professional Referees Association. I'm a professional referee. Thank you.
I remain Akani Udoite, a professional referee in the Nigerian Professional Football League. I'm the second timekeeper. Thank you.
Udo Wilfred Kanem, a PH teacher, Federal Government College.
By name Ubok Idon Serufon, a teacher in Brainstorm Academic, teaching PhD.
My name is Bright Benjamin Michael. I am a physical and health education teacher in King's Kids Christian Academy. Thank you.
Good evening, everybody. My name is Enobong Edets. I am a physical education and health education teacher, State College, Ikorek Bene.
Good evening, everyone. My name is Joseph Ime. I'm a member OSHA, UK, Nigerian region, Akwa Ibom State branch. I'm here as an independent observer.
I remain Daniel Edets, a PhD teacher in All Nation International School, Await Housing. Thank you.
All right, ladies and gentlemen, I thereby declare MC Calculus Math-A-Thon open. I thereby declare this marathon open in the name of God the Father, amen, and of the Son, amen, and of the Holy Spirit. Amen. Good day, students. I am starting something special with you, which is mathematics. Mathematics is a very interesting subject, and today's date is 20th of April 2024, and my first topic is equation. Then, when we talk about equation is a mathematical statement that shows equality between two expressions. We have different forms of equation. We have the linear equation, we have the quadratic equation, we have the cubic equation, and I am starting with linear equation. You see, linear equation is a mathematical statement that contains only one term and one variable and constant, and the highest value of x is 1. You see, we got linear from the word line. See, the word line, we have linear. And if you plot a linear graph, it's going to be a straight line. A straight line. And so, you can agree with me that a linear equation has the highest power of x and also contain a constant. You see, example of a linear equation is you have y equals to 5x plus 3. This is a linear equation. If you have an equation like 5x minus 13 equals to 15x minus 6, it is still a linear equation. If you observe in this expression, the value of x, the coefficient of x, irrespective of how it varies, but the power of x is 1. Another example of a linear equation is if you have like 6 into 4x plus 5 equals to 3 into 2x plus 2. All these are linear equation. And how do we solve this? We solve this by finding the value of different variables which are unknown. Let's see examples of how we can solve linear equation. Example number 1. Example 1. Example number 1. Solve the equation 12x plus 5 equals to 6x plus 23. 12x plus 5 equals to 6x plus 23. The first thing we do here is for us to collect like terms. The like terms here is that x, 12x, and 6x are like terms. So this will cross over to this side, collecting like terms. So this will give us 12x minus 6x, because if plus 6 will cross equality sign, and will turn from plus to minus. This will be equals to the 23 that was here will stay 23, then the plus 5 will cross, and when it crosses to this side, it becomes minus 5. So if you say 12x minus 6x, the answer will give you 6x. And if you subtract 23 minus 5, you have 18. Then for us to be able to get the corresponding value of x, we divide through by the coefficient of x. And you can say that the coefficient of x here is what? 6. So we now say dividing through by 6. Are you following? So this will now be 6. X divided by 6 equals to what? 18 over 6. So you see that from here, 6 to cancel out 6. And 6 cancel 18, how many times? 3. So therefore, you see that we can have that the value of x equals to 3. You see that in this question, that the solution of this question is this. We've been able to get the value of that linear equation. Now, example 2. Example 2 of the linear equation. If you're given this, it says solve the equation (6b minus 11) equals to 5 plus 4b. Solution. You see that from this point, we have this unknown b in the left-hand side and the right-hand side. So, if you now write 6b, this will cross over to this other side, and you're having minus 4b equals to, you have 5. The minus 11 will cross over, it becomes what? Plus 11. So from this point, 6b minus 4b is what? 2b. And 5 plus 11 is what? 16. Beautiful. So the coefficient of x here is 2. So we have to divide both sides by that to get the value of b. And so we have that divide both sides by 2. Why do we do that? Because the coefficient of x for the equation of b is 2. So this place becomes 2b over 2 equals to 16 over 2. Now this 2, we cancel out this 2. And 2 cancels 16 how many times? 8. So my b equals to 8. That is the solution of example 2. Hope you are following. Yes, now, let's go to the next example so that you can understand it better. In example 3, you have a linear equation in a bracket. They say 4 into x plus 1 equals to 6 into x minus 3. From here, you have to expand and open this bracket. So if you open this bracket, you're going to get 4x plus, that's 4 times x is what? 4. Are you with me? Yes, now 4 times 1 is what? 4. Equals to, you also open the bracket in your right hand side, which will give you 6 times x is what? Minus 6 times minus 3 is what? Minus 18. So we still have to collect like terms, because you cannot add this with this. They are not like terms. So this has to cross over to meet x. So we have that. You see that my 4x minus 6x will now be equal to what? Minus 18 minus 4. Because minus 18 here is the landlord here, and the plus 4 crossing over we'll have to turn the sign to minus. And what do we have? 4x minus 6 will now give us what? Minus 2x. What is minus 18 minus 4? Minus 22. So for us to have the value of x, don't forget the coefficient of x is minus 2. So we have to divide both sides by minus 2. So if we divide both sides by minus 2, divide both sides by minus 2, that will now give us what? Minus 2 over minus 2. Don't forget that we have x here. Equals to minus 22 all over minus 2. So you can agree with me that minus 2 here will cancel out minus 2. And minus will cancel out minus. And 2 goes into 20 how many times? 11. So therefore my x equals to 11. Is that clear? Yes, now let's see example 4. Example 4. Example 4. You have this. They say, find the value of x. Now they write the question, which is in 3 minus into minus 3x minus 2 minus into x minus 2 x minus 3 equals to 0. In this question, you see there is a minus outside the bracket. So for us to do this solution, you observe that in that question we have 3 minus into minus 3x minus 2 minus into x minus 3 equals to 0. So we have to open this bracket. If you open this bracket, we have 3 into minus gives us what? Plus 3x. Minus and minus is what? Plus 2. Open this one, what do you have? Minus x plus 3 equals to 0. Are you with me? From there we now still collect like terms. So that since the unknown, the variable x, the unknown variable x, let's take it to the left hand side. We have that 3x minus x will now be the constant 0 here. 3 minus 2 plus, this plus 3 will now cross becomes what? Minus 3 equals to 0. So you know that even if, look up 3 minus is plus 3x, minus times minus is plus 2, minus times x is minus x, minus and minus is plus 3. Now this 3x is here, the minus x is here. Then look at this 3, when it crosses, it becomes what? Minus. The plus 2 cross and becomes what? Minus. And the plus 3 cross and becomes what? Minus. And so if you observe, the coefficient of x is what? 1. So just like saying 3 minus 1, that's what? 2x. So this place becomes 2x equals to minus 3, 0 minus 3 minus 2 minus 3 is what? Minus 8, because this is minus 5 and minus 8. So we are still looking for the corresponding value of x. And what is that? We divide what? We divide both sides by the coefficient of x, which is what? 2. Are you following me? Yes, sir. So this is going to be 2x over 2 equals to minus 8 over 2. So x will cancel out x. The 2 cancel out 2, so that x will now be 2 cancel how many times? 4. So x equals to what? Minus 4. That is how we got the value of x in that particular question. So, what if we have an equation that contains a fraction? What do we do in a case like that? Equation that contains a fraction. Let's say an example of such an equation. We are still on equation and we are still on linear. So the subtopic is equation. Let's say linear equation involving fraction. Example of this, so we talk about a linear equation, this doesn't contain a fraction, but a fraction is in a case you have an equation is a linear, but it has a fraction in it. Example, you see 2y divided by 7 plus 5 equals to 9. Look at this. This is a fraction. Have you seen that? So if you have this kind of fraction, what do? We can find the LCM of 7 and 1. Any number is to the power of 1. So if you can find the LCM of 7 and 1, we can solve this easily, which is still the same thing as saying multiplying all through by 7. If you multiply all through by 7, let's think that this is an example. We call this example 5, still on the linear. Because we are still on linear, example 5 of linear. They say solve this. Let me write as a question. They say solve. Now you have that question. 2y over 7 plus 5 equals to 9. So we can find the LCM. LCM. The LCM of 7 and 1 is 7. Have you seen that? So we have to multiply through. Multiplying through by 7. So we say multiply solution. Multiply through by 7, which is the LCM of 7 and 1. So let's multiply. We have 7 times 2y over 7 plus 7 times 5 equal to 7 times 9. Multiplying all through. So 7 will cancel out 7. Are you with me? Yes, so this is going to give us 2y plus, what is 7 times 5? So you have a 35 equals what is 7 times 9? 63. So from there, we want to find y. So you have to collect like terms. The constants will have to cross over to this side. So we have 2y equal to 63 minus what? Because the plus 35 crosses. And it was plus. So when it crosses, it becomes what? Minus. So at that point, we have that 2y will now be, what is 3 minus 35? 28. So this is going to give us 28. And for us to get the value of y, we have to do what? We have to multiply or divide through by 2, which is the coefficient of y. So we now say divide through by what? 2. So this place will now be 2y over 2 equals to 28 over 2. Are you there? Yes, sir. So this will cancel out this. You have y left. And 2 cancel here, 1. Cancel 8 how many times? So therefore y equals to 14. That is the answer to that particular question. And we go to the next question, which can be example 6. Example 6. Wherever you don't understand, I'll give you time to ask questions so that we can flow. So example 6 is 3 over 4. It says solve the equation. Solve the equation. 3 over 4 into x plus 2 equals to x minus 2. This is an equation, linear equation. So you want to solve this equation. So for solution, we can see that the LCM here is 4. The LCM is 4. So we have to, LCM is 4. You've seen it. So we have to do what? Multiply it through by that 4. So we multiply through by 4. This will now give us what? 4 times 3 over 4 into x plus 2, then equals to 4 into x minus 2. While I put this bracket, it's because if you don't put this bracket and allow it to be like this, the 4 will only multiply with x. So this bracket shows that this 4 covers both x and what? Minus 2. So from there, this will cancel out this. So you have 3 into x plus 2 equals to 4 into x minus 2. So from that point, we are going to multiply this out. Multiply this out. 3 times x gives us what? 3x plus 3 times is what? Equals to 4 times x is what? 4 times minus is what? Minus or 8. We have been able to expand and open the brackets so that we can be able to now collect like terms. So from here, we now collect like terms. So if you collect like terms, you're going to have 3x will stay, 4x will cross. Is that correct? Yes, sir. When the cross becomes 3x minus 4x equals to minus 8 is remaining in the right hand side, while the pluses will cross. When the cross, it becomes what? Minus 6. So 3x minus 4x will be what? Minus x. This place becomes minus x equals to what? Minus or 14. When you have two minus, you add. There's a hidden plus in between here. So when you add, the minus still remains. So when you now have that value, the coefficient of x is what? Minus 1. So for you to clear off that minus 1, you have to do what? Divide both sides by minus 1. So if I divide both sides by minus 1, it's just more or less the same thing as minus here, cancel out this minus. Are you with me? Yes, sir. So that x will now be equals to what? 14. So we've been able to get the value of x to be 14 in that linear equation. So if you have another example, let's see how we can solve example 7. example 7. We are still on linear equation involving fractions. So, example 7. Example 7. Let's say solve the equation. Solve the equation n minus n over 6 equals to 5 over 6. Look at that value we have. We have a fraction written n over 6. We also have a fraction written 5 over 6. Now from this expression, you can see that the LCM is 6. LCM is 6. Now since LCM is 6, because this is over 1, if you want to find LCM, you have 6. So you have to multiply all through by 6. So solution, you now say LCM equals to 6. So we have to do what? Multiply. We are going to multiply all through by 6. So multiply through by 6. This will now be what? 6 times what? N minus 6 times n over 6 equals to 6 times 5 over 6. So what is 6 times n? That is 6n. This will cancel out this. Is that true? Yes. So we have minus n equals to this will cancel out this. What is now left? 5. So this place becomes 5. And this is 6n minus n is 5n. So 5n equals to what? 5. So when we divide both sides, by 5. My 5n over 5 will now be what? 5 over 5. So this 5 will cancel out this 5. So what do we have? We have that n equals to, this cancel out this 1. So my n equals to 1. That is the answer. So since we're able to solve questions that has to do with fraction, let's see how we can go into word problems that would lead to linear equation. You know that in most cases, some statement can be expressed in mathematics form, and this can change the meaning to what is contained in original statements. So if we have those values that is given in word problems and we are asked to solve, we have some certain steps we have to follow. The first thing is that when you have such an expression, you choose any alphabet to represent the number you are looking for. Let's say you choose X, or you choose Y, or any alphabet of your choice. Then you have to change each of the statements in the question to statements containing the letter you have chosen. As a second step, you now link up all the part of the equation to form an equation. When you do that, you can see that you are going to be able to solve such word problems. Let's see an example of what I'm talking about. If you have word problems leading to linear equation. Remember what I told you, in solving cases like this, you have steps you have to follow. The first step is to choose a letter to represent the number you are looking for. Let me just write it down for you. Steps to follow. Steps to follow. First is choose a letter to represent the number required. Choose a letter to represent. Choose a letter to represent the number required. And the second step is that letter must represent a number, not quantity. That letter must represent a number, not quantity. If you say let X represent maybe value 5, not quantity, not much, a particular number. That's what that point is telling us. And point 3, you should change each statement in the question to a statement containing the letter you have chosen. That is, you can say change each statement in the question to represent the letter you have chosen. Then the last step, which is number 4, is link up all the part of the question to form an equation. That is, link up all the parts of the questions to form an equation. Those are the steps you have to take. Now let's see how we can solve one. They say a man is 4 times as old as his son. We call that example 8, still in the linear equation. They say a man is 4 times as old as his son. As old as his son. In 4 years' time, he will be 3 times. He will be 3 times as old what are their age now? What are their age now? Now remember the steps. Remember the steps that I told you. First, choose what? Choose a letter to represent the number we are talking about. Abi? So, we can choose letter A. So we say let the son H be A. Solution. Since we have seen the steps, let's see how we can use that steps to solve. Solution. A man is 4 times as old as his son. So let the son H be A. Let the son's H be A. So the father H will not be what? If the son is A, and I say the father is 4 times. Have you seen the question? A man is 4 times as old as his son. So if the son is A, the father H will not be what? 4 times A. So now you now say, then the father's H will not be, father's H will be 4 times A, which is 4A. That is 4 times the son. So 4 times A will give us 4A. So in 4 years, in 4 years' time, he will be 3 times as old. In 4 years' time, in 4 years' time, he will be 4 what? So in 4 years, the age of the father, the age of father will not be what? Look at the father's age for now. So in 4 years, you add 4 to the present age. Is that true? So that will be the what? 4A original age plus the 4 years. And the son, if the father is this, the son was A. So if you add 4 years to A, what would be that? A plus 4. Are you following me? So this one is 3 times as old. 3 times as old as this. Look at this statement. He will be 3 times as old. That is to say, that place will not be what? 3 times as old will not be 4. A plus 4 equals to 3 into A plus 4. As old. So now multiply that, we are going to have 4A plus 4 equals to, open this bracket. What is 3 times A? So that will be 3A plus 3 times 4 is what? So we now collect like terms. If we collect like terms, we have 4A minus 3A equals to 12 minus 4. So 4A minus 3 is A. So that place becomes A equals, what is 12 minus 4? 8. So you see that the son age will be 8 years old, because we say that A represents the son. So if the son age is A, son, which is A, equals to 8. And what was the father? The father was 4A. Abi? So therefore the father equals 4A. 4 times what? 8. Multiply 4 times 8. 32 years. Example 9. I subtract 3 from a certain number. That result. I subtract 3 from a certain number. I multiply the results by 5. I multiply the results by 5. And then at 9. If the final result is 44, find the original number. Find the original number. So from the context of what I told you, the number we're looking for must have an alphabet, right? Subtract 3 from a certain number. So we can say let the number be any alphabet of your choice. Is that true? So if you say A, whatever, whether A or P or Q or R. So if I say let the number be P, I subtract 3 from a certain number. Subtract 3 from a certain number. Look at this. Subtract 3 from P. Subtract 3 from P. What will be the answer now? That will be P minus 3. Subtract 3 from P. Have you seen that? Now, multiply the result by 5. This result, I multiply it by 5. Look at this. I subtract 3 from a certain number. Certain number is P. Have you? So subtract 3 from P is what? P minus 3. Are you following me? Yes, what's the next step? Multiply the result by 5. What's the result of this? P minus 3, have you? Yes. So if I multiply the result by 5, let's write the statement. Multiply the results by 5. That would now be what? 5 into P minus 3. You don't say 5 times p minus 3 is very wrong. Because the 5 will only multiply with p. Is that clear? So we finished that step. What is the next step? You say? Add 9 to the result. So add 9 to the results. This is the results, Abi? So we add 9, it's going to have what? 5 into p minus 3 plus 9. We have finished that step. What is the next step? Have you seen that with that step we've been able to solve it very well? The final result is what? 44. So final results is 44, meaning 5 into p minus 3 plus 9 equals to 40. So we've been able to turn that word problem into what? A linear equation. Are you following me?
Yes, sir.
So from that point, what do? We have to expand. Expanding this, 5 times p is what? 5 times is what? Minus 15. Plus what?
Plus 9.
Equals to? Now, 5p, we can add up this. Minus 15 plus 9, what do we have? Minus 6. Because just like saying 9 minus 15, that will give us minus 6 equals to 44. Are we together?
Yes, sir.
So we now collect like terms. The constant of minus will cross. And you know that anytime minus will cross, it turns to what? Loss. So this place becomes 5p equals to 44 plus 6. So that 5p will now be, what's 44 plus 6? 50. So we divide both sides by what? 5. We divide both sides by 5, what will happen? My p will now be 50 over 5. Is that correct?
Yes.
So this will cancel out this how many times? 10. So my p equals to 10. Look at how the question was, as if it's something very difficult. But you can agree with me that if you follow these steps very well, that the corresponding value what you're looking for will come out. Because they say, do it step by step. I subtract 3 from a certain number. So if the number is p, I subtract 3 from it. Now the next step is what? I multiply the result by 5. The result of this, multiply by 5. Are you with me?
Yes, sir.
Now, what did they say? Add what? 9. I've added 9 to that. And the result is what? 44. So we now get this, it has turned to a linear equation. So we now get the linear equation. We now use the expansion value here. We collect like terms and divide the coefficient of x, the coefficient of p, and get the value of 9. I hope you're following me.
Yes, sir.
So please, you guys are enjoying the business.
Yes, sir.
We need to be interactive so that we can flow.
Yes, sir.
I told you that mathematics is fun. So let's go to example 10. Example 10. As I'm doing it, you can also do it yourself. Don't forget, after after 1 hour, I'm going to give you time to ask questions. So as I'm teaching, you don't understand, just keep your question and ask. Let's go to example 10. It says, a father is 3 times as old as the son. 9 years ago, 9 years ago, the father was 4 times as old as the son. Find their present age. find their present age. Don't forget the steps that I told you you're going to follow. The steps you're following will guide us. No matter how mathematics is difficult, just follow the steps. The steps, if you take care of the minutes, the hour will take of itself. Look at this. Let's reason together. Come, let's reason mathematics. A father is 3 times as old as the son. The first step, remember what I told you. You have to represent with an alphabet first. So, a father is 3 times as old as the son. So the son is the subject matter, right? Yes. So you now say, let the son age be any alphabet like Y. Solution. Solution. Let the son age be Y. Now let's go back to the question. A father is 3 times as old as the son. 3 times as old as the son. So if the son is Y, what's the age of the father? 3Y. That's 3 times Y. So from there we have that father is 3 times as old. 3 times as old as son. Look at the son. The son is Y. So 3 times as old as son will now be what? 3 times Y, which is equals to 3. The way we are flowing, no matter how the question is hard, you can do it. Because just for you to follow up the principle. We've been able to know this. Now, they say 9 years ago, the father was 4 times as old as the son. 9 years ago. 9 years ago. So if you say 9 years age of the son is what? 9 years ago. Look at this. The son is Y. So if you want to talk about, if you want to know the son's age as at 9 years ago, what do we do? No. You say? Y minus 9. So this is going to be for the 9 years ago. 9 years ago of son. 9 years ago of son. What will now be? Y minus 9. That's 9 years ago. Are you following? Now, if you want to talk about 9 years ago of the father, what's 9 years ago of the father? 9 years. 9 years ago of father will now be equals to what? 3Y minus 9. Have you seen the tricks involved in the business? Now, father 4 times as old as the son. In that 9 years, look at this. 9 years ago, the father was 4 times as old as the son. In that 9 years ago that this two has been established, the father is what? 4 times as old as the son. So that is to say that father 4 times as old, father 4 times as old as son. Father 4 times as old as son will now be 4 into Y minus 9 equals to 3Y minus 9. Because father is 4 times as old as the son. This is the son, and father has to be 4 times as old as the sun. Are you getting me? So we can see that from there we will be able to form a linear equation. So no matter how the equation is complicated, if you follow that steps, you can get the answer easily. You don't have to be intelligent to know math. Just follow the example and go ahead in solving problems. If you don't mind the example, you end up in shambles. So we now multiply 4 times y. You're going to get what? 4y. Then 4 times minus 9. 4 times minus 9 is what? 36. Labels will now be minus 36 equals to 3y minus 9. So we now collect like terms. We collect like terms. This place will now be what? 4y minus 3y equals to minus 9 plus 36. Because the minus will cross and becomes plus. So if you subtract 4y minus 3y, what do we have? Y equals to minus 9 plus 36 is less than 36 minus 9. And that will give us what? 27. So you see that y was what? The sun's age. Abi? So you can now say that the sun's age equals to what? 27. And if the son's age is 27, remember the father's age was what? 3y. Abi? So if the father's age was 3y, therefore means that father's age will now be 3y, and y was for the son. So the answer will now be 3 times 27. If you multiply 27 by 3, 7 times 3 is what? 21. This was 6 plus 2 will now give us what? 81. So this place will now be 81. So you see that the son's age is 27, while the father's age is what? 81. So with that, we've been able to solve questions that has to do with word problems. The next subtopic we want to discuss is linear graph. Linear graph. Linear graph. And you observe that linear graph is quite interesting. Linear graph is quite interesting. Remember what I told you, that from the word line we have linear. So equation of the form, you have equation of the form y equals to bx plus c. You see, this is a straight line graph. A straight line graph where b is the slope and c is the intercept. So you say equation of the form there is a linear graph. And now in this linear graph, this b you see here is the slope. So b equals to the slope. You can call it gradient. And the c is the intercept in the x-axis. So we can find the corresponding value of x. We can also find the corresponding value of y. If we have a linear graph like this, for us to be able to plot that graph, we set the value of x to be 0 in order to have y. And we set the value of x to be 0 in order to have y, and set y to be 0 in order to have x. And from that, we now use those points to plot the graph. And when we plot that graph, we're going to have a linear graph. Let's see an example. We want to plot this graph. Let's plot this graph. Example 1. Example 1. Solve graphically. Solve graphically y equals to 2x plus 4. We want to plot the graph of this. So solution. In the equation we have y equal to 2x plus 4. And then, remember what I told you, that this equation meet x-axis when y equals to 0 at 4. So for us to be able to get the corresponding value, we now say set x equals to 0 for y. So in this case, what do we have? Y will now be 2 into 0 plus 4. Is that correct? So if you now multiply that, my y will now be equal to, you know that 2 times 0 is 0 plus 4, which will give us 4. So in the first point of the graph, point A of the graph, you know, in a plane of the x and y coordinates, we have the x and y written this way. And so in the first point, when x is 0, my y is 4. And then from the corresponding value of y equals to 0, when y equals to 0, we put 0 here. This will be 0 equals to 2x plus 4. And now since we are looking for x will cross over, a plus will turn to what? Minus. So 0 minus 2x will now be minus 2x equals to 4. So dividing both sides by minus 2, we have that x will now be what? 4 over minus 2. Is that true? So therefore, minus 2 cancel out how many times? There's a minus here. So therefore, my x will now be equals to minus 2. So this was the first point of the graph. When x equals to 0, y equals to 4. So for my point B, x is minus 2. What is the value of y? Y equals to what? 0. So we are going to plot that graph where we have a linear graph. So you know, in the Cartesian plane, we have the x and y coordinates. We are still on linear graph. So we've been able to get the corresponding value of A, point A. Let's write points. Point A, 0 and 4. Point B, minus 2 and 0. So you want to plot this graph. We want to do a sketch of our graph. It's a sketch of which we have, this is my x and y coordinates, where the origin is 0. And this arrow shows that this graph is continuous. When you're plotting a graph, you need to put this arrow. If it doesn't put this arrow, it doesn't give it a good meaning of a graph, because graph is continuous. And now you see that the highest value of this is x and this is y. X and y. The highest value of y is 4. So when we are talking about the x-axis and the y-axis, there's a positive y, negative y, positive x, and negative x. So in the y-axis, the highest value is 4. So when we are having this point of y, we have to make sure that the value we are using contains 4. And what we can do there is that in this expression, we can also be able to get the corresponding value of x. So the scale in the y-axis, if you use the scale of 1 cm representing 1 unit, this is going to be 1, 2, 3, and 4. And we can also see that 4 will be included in a range. Then for the x-axis, the highest value is -2. So we have here 1, 2, 3, then -1, -2. Then for the y-axis, this is a negative value, -1, -2, -3, wherever, so long as the x-axis has -2, the graph will contain. And so long as the y-axis has 4, this graph contains 4. So you see that the scale we are using both in the x and the y-axis is 1 cm to represent 1 unit. So for point A, when x is 0, y is 4. So when x is 0, this is x 0, y 4. We cut that point. That is my point A. When x is 0, y is 4. And when x is -2, x -2, y 0. X -2, y 0 is this point. So we are going to join these 2 points. This is my point B. We join these 2 points to have my linear graph. So that is the graph of y equals to 2x plus 4. And if you see very well, you can agree with me that if you solve this linear equation, the solution will be the value you have here. That's what I'm talking about. If you have y equals to 2x plus 4, and you solve this equation by setting x to be equal to 0, that is, if y equals to 0, you have 2x plus 4 equals to 0. You see that 2x will now be equals to -4. And you want to find the value of x here. X will now be -4/2, which will give us what? X equals to -2. So the solution of this graph is where the graph cuts at x-axis. So from that point, we have the solution of the graph. So graphically, we still have what we have when we are solving. And this is the solution of the graph. This is the solution. That's the solution of the graph. Where x equals to minus 2. So if you are given two linear equation, and you're asked to plot the graph, two linear equation, and you're asked to plot the graph, let's see what you are going to get. Two linear equation, and you're asked to plot the graph. That is to say, we are going to have two graphs in one Cartesian plane. They say plot the graph. Plot the graph of y equals to x plus 2 and y equals to 4x minus 7. Plot that graph. These are two linear equations in one. So, from one, solution, y equals to x plus 2. I call this equation 1. Y equals to 4x minus 7. I call this equation 2. So from equation 1, y equals to x plus 2. I want to solve it one by one. So from equation 1, remember what I told you. Set x equals to 0 to get what? Y. Maybe? And set y equals to 0 to get what? X. So from that point, what do we have? When x equals to 0, put 0 there. You can even use your eye to see the answer. So y will now be what? 0 plus 2. Is that true? So that will now be equals to 0 plus 2 is what? 2. So we get that my y equals to 2. So for that point, first point A, when x is 0, y is 2. Are you with me? Now, we now come to where we want to also set when y equals to 0. Now say when y equals to 0, we put 0 here. What happened? 0 equals to what? X plus 2. In that case, from here, my x will now be what? Minus 2. Because minus 2 will cross, have you? So x equals to minus 2. So for my point B, we write x before y. So x is minus 2 and y is what? 0. Then in this expression, we see that we can able to get the corresponding value of x. So from equation 2, y equals to 4x minus 7. Y equals to 4x minus 7. In this expression, we can able to set x when x equals to 0. We can get the value of y. Is that right? So that for my y will now be 4 into 0 minus 7. So 4 into 0 minus 7, 4 times 0 is what? 0. So therefore my y will now be 0 minus 7. Give me y to be equal to 7. So when y equals to 0, you put 0 here. So when I put 0 here, 0 will now be equal to what? 4x minus 7. Since I'm looking for the value of x, x will cross over. That will be what? Minus 4x equals to minus 7. So this minus can cancel out this minus, and my x will now be what? 7 over 4. Which 7 over 4 can be 7 divided by 4. Press it for me. What do you have? 1.75. 1.75. So at this point, we call this point A, we call this point B. I can call this one point C. At point C, x was 0 and y was 7. Y was minus 7. Now at point D, y is 0 and x 1.75. Y is 0. So you see that we can plot this graph. We can plot this graph. I want to use this board for the graph. If you have, remember this point. Okay, let me just make the graph big. Let me use this place so that we centralize the graph. If you have this, let me centralize the graph. The highest value we have here is in y-axis. Look at the highest value we have in y-axis. Is for y have 0, we have 0, we have 1.75, we have minus, we have 2 here, minus 7. So if you now draw this, we call this point 0. Now, for the x-axis, we can call this one, 2, 3, minus 1, minus 2, don't forget you need to put this arrow in your Cartesian plane. So, look at this. We are using 2 cm to represent 1 unit here. Now we can also use another unit here that will make you have the value you are looking for. If it is 2, 4, 6, 8, 10, minus 2, minus 4, minus 6, minus 8. So that I have the value of minus 7 in y. Because this scale will give me the value of minus 7. And this scale will give me the value of 2. So in the y-axis is 1 cm representing 2 units. Then in the x-axis is 2 cm representing 1 unit. So what we now do there is that we start plotting the graph at point A. Look at point A. When x is 0, y is 2. X 0, y 2. This is my y-axis. So my point 2 is this place. When x is 0, y is 2. Then when x, for point B, when x is minus 2, y is 0. X minus 2. This is my x. Minus 2, y is 0. Where? This point, Abi? So we can join those 2 points to give me the first graph. That was the graph of y equals to x plus 2. Then, for this particular point, we have point C. When x is 0, y is minus 7. So this is x-axis. X is 0. Y minus 7 will fall in between minus and minus 8. Abi? So that will be the half of that. So the value of that will be the corresponding value that we are plotting in the graph. So this place will not be. Now the next one is when x is 1.75, y is 0. So x, this is 1 and this is 2. So the middle will be 1.5. So if you have those dots, maybe from here to here, if it was 2 cm, 1.5, 1, 2, 3, 4. So this is 1.5, 1.6, 1.7, 1.8, 1.9, 2. So this is 1.75. So the roasted value can be 1.5, 1.6, 1.7. So this place, you don't plot graph in the middle, plot graph in a line. So you cut here in 1.8 as a roasted value, and you join this point together. That is the graph of y is equals to 4x minus 7. You observe something that these two graphs meet at this point. Now where these two graphs meet, if you drop that point to the x-axis, you have the solution of that two graphs. If you solve these two equations as a linear equation that it is, the answer will give you 3. This is what I'm talking about. You have y equals to this, y equals to this, means that this equals to this. If y equals to x plus 2 and y equals to 4x plus minus 7, it therefore means that x plus 2 equals to 4x minus 7. So this place will now be, if you say x plus 2, let me take it to this point. If you say x plus 2 equals to 4x minus 7. From here we collect like terms, right? If you collect like terms, this block will be that x minus 4x equals to what? Minus 7 minus 2. Abi? So x minus 4 is what? Minus 3x. Minus 7 minus 3 is what? Minus 9. Is that true? So this cancels out this, and x will now be what? 9 over 3. Abi? So this will cancel out how many times? 3. So therefore x equals to what? 3. So you see that if you solve these two graphs, the solution will give you what you have in the graph. So from that point, we've been able to get the solution of that graph. All right, now let's see how we can solve simultaneous equation graphically. Graphical solution of simultaneous equation. I hope you've taken note of this. In the next 20 minutes, I'll give you time for questions. So you have any question, you're free to ask. Because you need to know mathematics. Every world must know mathematics. Because mathematics is part of life. So we are still in linear graph, but this time around we are solving simultaneous equation. Solving simultaneous equation graphically. Now question, this was example 1 in graph. Now example 2 in graph. This says solve the simultaneous equation graphically. 4x minus 5y equals to 12. 4x minus 7y equals to 8. Remember what I told you? You have to find the value of x and y in the first equation, and also find the value of x and y in the second equation. You now use those points to plot the graph. And don't forget, where the 2 points meet is the solution of the graph. So let's see what will happen. Let's see what will happen. Now, solution. I call 4x minus 5y equals to 12, equation 1. I call 4x minus 7y equals to 8, equation 2. Now, from equation 1, what is equation 1? 4x minus 5y equals to what? 12. So you have to set x equals to 0 to get y. Abi? And set y equals to 0 to get what? X. So what do we do now? Say when x equals to 0, you have 4 into 0 minus 5 y equals to 12. 4 times 0 is a 0. Abi? Yes. This place will now what? Minus 5y equals to 12. So from there we can get the corresponding value of y by dividing through by minus 5. If you divide through by minus 5, you're going to have that y will now be 12 over minus 5. And 12 divided by minus 5 will give us minus 2.4. So we can get 2 points in that first graph. Now when x equals to 0, y equals to minus 2.4. I call that point A. When x equals to 0. So when y equals to 0, we put y here. So from that point 4, x minus 5 into 0 will now be equals to 12. 4x minus 5y. So you'll be able to put 0 there to get the value of x, right? So my 4x, see that minus 5 times 0 is gone because it's 0. And 4x minus 0 is what? 4x equals to what? 12. So what do we do? Divide both sides by 4. My x will now be what? 12 over 4. Which cancel this how many times? So therefore x equals to 3. So when y equals to 0, x is 3. When y equals to 0, when x equals to 3, y is 0. So we've been able to get the 2 points for the first form of that equation. let's see how we can solve to get the corresponding value of the second equation. We finished equation 1. Maybe? So, from equation 2, 4x minus 7y equals to 8. So when x equals to 0, what happened? 4 into 0 minus 7y equals to what? 8. I have substituted the value of x there. And you know that 4 times 0 is what? 0. 0 minus 7y is what? Minus 7y equals to 8. So we want to find y now. Y dividing through by minus 7. Y will now be equals to what? 8 over minus 7. And 8 over minus 7 is what? Minus 1.1, for that minus 1.1. So from there we can agree, if I got that point C, x is 0, y is minus 1.1. That was when x equals to 0. So when y equals to 0, when y equals to 0, you substitute the value of y there in equation 2. Don't forget this was equation 2. So what happened? 4x minus what? 7 into 0 equals to 8. Is that true? So multiplying 7 with 0 is 0. 4x minus 0 will give us 4x equals to 8. So dividing both sides by the coefficient of x, my x will now be what? 8 over 4, which gives us what? 2. So that is the value of x. So in this case, you can agree with me that when x is 2, y is 0, because I have to write x before y. I call this D. So with this, we can plot the graph. You have this point, this point, this point, this point, and this point. Look at it critically. X falls in the range of 3 in the positive, while y falls in the range of minus 2.4. So we want to take a scale, it must cover those two values. So let's see how it goes. If you have the graph, we want to plot that two graph. The graph of 4x minus 5y and 4x minus 7y, all equal to 12 and 8 respectively. This is what we're going to have. At the first point of the first graph, this graph will cover those 2 points. Don't forget the highest value of x is 3, assuming we use the same scale in both axes. I call this 1, 2, 3. 1, 2, 3, minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. The first point, when x is 0, y is minus 2.4. This is minus 1. When x is 0, y is minus 2.4. X, this is 0 points. Minus 2.4 is here because this is minus 2. Minus 3. Minus 2.4 will be closer to the center of this. So if I cross that point, if I cross this point, I will have something like this there. For the first point, when x is 3, y is 0, x3, y0, this place, right? x3, y0. We can still extend this to 4, to 5, to 6, because it's continuous. Now we draw that point so that this place will be like this. It's a sketch. That's a graph of 4x minus 5y equals to 12. Now the second graph is what we want to plot. When x is 0, y is minus 1.1. x 0, y, this is y, minus 1.1 will pass minus 1. That is the next point, you put it here, minus 1.1. Now, for this one, when x is 2, y is what? 0. When x is 2, x 2, y 0, this place. So you now join the 2 points. When you join the 2 points, if you're using graph to join, you have something beautiful than this. This is just a sketch work. We have this, join. Or we have this one, join. The first graph was a graph of 4x minus 5y equals to 12. And the second graph is a graph of 4x minus 7y equals to 8. So when these two graphs meet at this point, if you're using your graph, you see how it goes. So I will cut at that point. This is just a sketch work in your graph. You're going to see something like 5.5 here, which happens to be the solution of the graph. So that is how we use graph to solve simultaneous equation when the 2 points meet. So now we want to go into simultaneous equation proper. You see, when you have two unknown quantities whose value is determined, we have simultaneous equation. Simultaneous equation. So when there exist two unknown quantities whose value are to be determined in two equations at the same time, two unknown quantities, quantity x, for example, and quantity y. And now we want to solve the two unknown variables at the same time. You see, we are solving that equation simultaneously. And we have two common methods of doing that, either by substitution method or by elimination method. So we are going to start with elimination method. Elimination method. So in this elimination method, it requires you to first eliminate one of the variable. Then you find the remaining variable via substitution. As the word eliminate, eliminate means remove, kill, quench, Do you understand? So we have two variables. We have to eliminate one. Because if you don't eliminate one, the other one will not survive. Are you following me?
Yes, sir.
So if you have x minus 2y equals to 8, this is example 1. X minus 2y equals to 8, and 2x plus y equals to 5. X minus 2y equals to 8, and 2x plus y equals to 5. Elimination method. Solution. Solution. We have to solve. So, if we want to eliminate anything, we should try to see how we can make that thing we want to eliminate to have the same value. For example, look at this, 2x here. The equation of x is what? 1. If we make this place to be 2, and we say 2 minus 2, what happened?
0.
It's 0. Abi?
Yes, sir.
So, we can multiply all through by 2 in equation 1. You multiply equation 1 by 2, this place can turn to 2. Or we can use another method by saying we have x minus 2y equals to 8, 2x plus y equals to 5. We call this equation 1, we call this equation 2. So from here, we can say equation 1 times this 2 we have here. And we say equation 2 times this one. Just like interchanging this with this and this with that. They marry each other. Like exchanging something to share in common. So, if you multiply this with this and this with this, the two places will have the same value. Agree? So that place will now be equation 1 times 2 will now, all of them will now be what? 2x. 2 times x is what? 2x. 2 times minus is what? Minus 4y. 8 times is what? Now multiply 1 with this. What do you have? 2x plus y equals to 5. Because 1 times that is that. Then at that point we have, this is, we can call this equation 3, call this equation 4. They now look alike. They can be eliminated. So we now say equation 3 minus equation 4. This minus this, so 2x minus 2x is gone. Abi? Minus 4, this is equation minus here. So minus 4 minus y, just like saying minus 4 minus 1. Minus 4 minus 1. What is that? Minus 5y. Is that true? Then 16 minus 5 is what? 11. So what happened next? We can say that if we divide through by minus 5, y will now be what? 11 over minus 5. Which if we divide 11 by minus 5, you're going to have, what is 11 by minus 5? Yeah? Minus 2.2. That is the value of y. So we now substitute the value of y using either equation 1 or equation 2 to get the value of x. So let's see what will happen. We use equation 1. In equation 1 we have, now say put y equals to minus 2.2 into equation 1 because we want to find the value of x. So we can say x minus 2 into, if you put this 2.2 here, is approximated value, right? You put this one, may not give you the exact value you are looking for. So we're going to use this corresponding value of y, which is a minus 11.5. So you now put minus 11.5, that will be minus 11 over 5. And this place equals to 8. Wherever we see the value of y, we substitute this. So therefore this would now give us minus and minus is what? Plus. And 2 times 11 is what? Over 5 equals to what? 8. So from there, the constant will cross. So that x will now be what? 8 minus what? So if you now find the LCM of this, x equals, what's 8 times 5? 40 minus 22. 40 minus 22 will give us what? That will be 18 over 5. So x will give us 18 over 5. So can you divide 18 over 5? 3. 5 goes to 18 3 times. Remember that 3.6. So therefore x equals to 3.6 and y equals to what? Minus 2.2. That is how we solve simultaneous equation using the method of elimination. Okay, let's try example 2 to see how we can do that. Example 2. Example 2 says, solve the equation solve the equations 3x plus 5y equals to 47, 2x plus 3y equals to 29. So remember what I told you, you can choose to eliminate x, you can choose to eliminate y. At the first time, you still have the same answer. So solution, I call this 3x plus 5y equals to 47. I got this equation 1. And 2x plus 3y equals to 29. I got this equation 2. So we can make x to look alike so that we can eliminate. So we now say equation 1 times 2, because we multiply this with this is 6. This with this is still 6, so the thing will have the same. Now also multiply equation 2 with what? 3. So you multiply 2 with 3x, what do you have? 6x, Abi? Plus 2 times what? 47 times 2. 94. You can call that equation 3. And now multiply 3 with this. 3 times 2x is what? 6x. 3 times 3 is what? 9y. 29 times 3 is what? Huh? What do you say? 87. That's equation 4. So you see that x and x are the same. So it can be eliminated. Is that true? Yes. So this place will now be, you can now say equation 3 minus equation 4. Abi? So this minus this. 6x minus 6x is gone. Abi? So 10 minus 9 is y. 94 minus 87 is what? 7. You can see that y equals to 7. So we can use either equation 1 or equation 2 to get the value of x, which will still give you the same answer. So from that point, this is what we have. Put y equal to 7 into equation 1. Abi? Yes, so this place will now be 3x plus 5 into 7. You put 7 in the way you have y. So this place will now be equals to what? 47. So 3x plus, what is 5 times 7? Equals to 47. So 3x equals to what? 47 minus 35. Have you seen that? Yes, sir. So from there, 3x will now be what? 47 minus 35? 12. We can now divide both sides by 3 because the coefficient of x is what? So what do you see there? My x will now be 12 over 3. My x equals to what? 4. Because 12 cancels this how many times? 4. So what do we say? We now say that, so therefore x equals to 4, y equals to what? 7. Let's go to something complicated than this. If we have a simultaneous equation that has a fraction, that is example 3. Any topic we are teaching, we're starting it slowly till we get to the top. Example 3. Example 3. Solve the equation 6 over x minus 4 over y plus 2 equal to 0. 14 over x minus 12 over y plus 4 equal to 0. Look at the question there. Before I proceed with this, I want to give you time for question. From what we've done, if you have any question, please ask before we proceed to solve this. This is an interactive time. So, if you ask question, yes. Where? Sir? From this point we have 3x equals to 12. So the coefficient of x here is 3. So we have to divide both sides by the coefficient of x. And the coefficient of x is 3. So we now say 3x over 3 equals to 12 over 3. So this cancels out this. Are you following me? So 3 cancels over how many times? 4. You have x to be equals to 4. Is that clear?
Yes, sir.
If that will keep him awake, there's no big deal. but preserve your energy so that you can stay. It's part of the interaction. We are interacting. So, any other questions? Any other question? Seems you are following very well. So, I want to give you this to try for me. Try to solve this for me. And you have 3 minutes to do that. 3 minutes to do that. Now, before I proceed with this, please try this for me. Let me see how far you understand what we are doing. You have 4x. Let's see, you have 3x plus 2y. (3p) plus 2p equals to 10. 2p plus 2w equals to 10. And p plus 2w equals to 2. Let's try that. You have 3 minutes to do that. We're interacting. So you have to do that. I want to believe you can understand what to do. If you finished, you tell me the answer. Yeah. P equals to 6. And W equals to minus 2. Any other objection? Yes. P equals to what? 2. W equals to what? Minus 1. Why do you have different answers? Wait. One person at a time. Yes. P equals to 4. Okay, P equals to 2. This is the same thing now. I was asking whether you have any objection. Yes. Please let me appoint somebody. Yes. P equals to 4 and minus 1. Yes. People are having so many great answers. Let's try and see how it goes. No, let's solve that and see. Let's solve this and see. Cool down. Let's solve this and see. You have 3p. Without wasting time, this look alike, you can eliminate. Abi? Even if you want to multiply, you still have the same thing. But if you don't want to waste time, you can eliminate W. Remember what I told you? You can eliminate any alphabet. Are you getting me? So this time around, they are the same. So if you now subtract 3p minus p is what? This one is gone, Abi? Equals to 10 minus 2. So p will now be what? 8 over 2. P will now be equals to what? 4. So if you have p equals to 4, you can use either equation 1 or 2. So from let me use 2. Anyone is say the same thing. From 2, p plus 2w equals to 2. I want to put p there. 4 equals to what? 4 plus 2w equals to 2. Abi? So what happened? 2w equals to 2 minus 4. Is that correct? So 2w equals to, what's 2 minus 4? minus 2. So but dividing both sides by 2. The rate will now be what? Minus 2 over 2. The answer is what? So therefore you can see that P equals to 4. W equals to minus 1. How many of you have gotten that? Brembo, do you have this? Yeah? You have that? Okay. Let me see. So that's the place you do the mistake. Hmm? All right, let's proceed to solving this. At least doing it yourself, you've learned. I mean, that my friend over there, did you have the answer? So you are very intelligent. Lovely. Okay. Let's see how we can solve this. You see, this question sounds so complicated. Abi? But it's very simple. We have two ways of solving this. You know that solution if we have this 6 over x minus 4 over y plus 2, we can cross this constant to the other side of the equation, have you? We can also cross this to that. Is that correct? So we can write, say, and you see that x 6 over x 6 over x can be written as 6 over x can be what? 1 over 6 times x. Is that true? Yes, sir. This is the same thing as this, because 1 times x, or it's going to be 6 times 1 over x. 6 times 1 is 6 over x. Huh? So we can present this solution. We can now say this is what? 6 times 1 over x minus what is here? 4 times 1 over y. Have you seen what I'm doing? Equals to this one will cross becomes what? Minus 2. I call this equation 1. Look at them, I want to make it simple. What's the next thing? 14 times what? 1 over x minus what? Equals to this one cross becomes what? Minus 4. So from there, I now say, let 1 over x equals to a and 1 over y equals to b, or any alphabet of your choice. Have you seen what I'm doing there? So this place will turn to what? 6 what? 6 what? Minus 4 what? Equals to what? This is my equation 1 as it was. And this place is what? 14a minus what? Equals to what? Equation. If everything was like this, we would have solved a longer time. Now, when you now solve this and get the value of a and b, you now come to substitute here and get x. Is that clear? So this place will now be from here. We can even observe that we can make it simple. We can simplify both equation 1 and equation 2. Is that possible? So I now say simplifying the two equations. You can stand to multiply. But you can also, so I want to show you that if you have a case that all the value has a common factor, you can make it easy. There's a factor of 2. Eh? So you can simplify to make the multiplication to be easy for you. So this place will now be, now the simplifying 1 and 2. Divide this by 2, what do you have? 3a minus what? Equals to what? You see my equation 1. Because I'm just simplifying it. Abi? I simplify this, what do you have? 7a minus what? Equals to equation. From there it's simple for me to multiply. Is that correct? So now it's equation 1 times, if I want to eliminate a, times what? Equation 2 times what? Are you with together? So let's multiply it. This times is what? 21a minus what? 7 times this what? Equals to, multiply 3 with what you have? Minus what? 18b equals to what? Are you okay? From there you can eliminate a easily. Subtract equation, if you call this equation 3, call this equation 4, you can say what? Equation 3 minus 4. That's minus this what? Gone. Abi? Now, minus is what? Plus. So minus 14 plus 18 is the same thing as saying 18 minus 14. Abi? So what's 18 minus 14? Eh? That would be 4b. Then minus is plus 6. So minus 7 plus is what? Minus 1. So if my b equals to minus 1 over 4. From this place we can get our a. Because this is b. Don't forget, what was my b? Eh? We can substitute here and get our y. Is that true? So therefore, what do we do there? We now say that my 1 over y equals to minus 1 over 4. Have you seen that? 1 over y equals to minus 1 over 4. So we can get y here. Is that true? If you cross multiply, what happened there? Y times minus 1 is what? Minus y equals to 1 times 4 is what? From there, if you multiply through by minus 1, this minus will come here, abi? So my y will now be equals to what? Minus 4. So we don't get y as minus 4. We can substitute here in any of this equation to get x. Or we still come back to this place and get a before we proceed. Is that right? But we don't want to waste that since we have gotten y already. You can just come back to equation 1 and put y here, we can get x. So what do we say? We now say put what? Y equals to minus 4 into equation what? Equation 1. So you put in equation 1, we are going to have something like this. 6 over x minus 4 over what? Minus 4. Are you with me? Yes, sir. Plus 2 equals to 0. So but that minus cancel the minus. Is that right? Yes. So minus cancel minus. 4 cancel for how many times? 1. So 6 over x plus what? 1 plus this 2 equals to 0. Abi? Yes, so what do you have there? 6 over x plus what's 1 plus 2 equals to 0. So 6 over x equals to what? Minus 3 when you cross. Is that correct? Yes, so from there we now cross multiply. If you cross multiply, this and this would now be what? That would be what? Minus 3x equals to 6. Is that true? Yes, sir. So therefore x will now be 6 over minus 3, which cancel out this how many times 2? So x will now give us minus 2. So you can now summarize that x equals to minus 2, while y equals to what? Minus 4. So that thing that was as if it was big, like upstairs, has turned out to be very simple. If you put the value of x and y in this place, you get 0 at the end of the day. So let's go to substitution method. Substitution method. Substitution. Substitution method. So in this method, we manipulate one of the equation such that one variable is defined in terms of the other. That is to say, one of the unknown is made subject of the formula. You make one unknown subject of formula, then you now substitute in the other equation. If you use equation 1 to make x subject formula, you put it inside equation 2. If you use equation 2 to make subject of formula, you put it inside equation 1. If you make equation 1 subject formula and still put inside equation 1, you are still going to get back that equation. So you have to interchange the subject of formula. So let's see if I use, in this example, example 1. 3x plus 2y equals to 10. X plus 2y equals to 2. You're asked to solve this equation using substitution method. So you can choose to use any of the equation, whether equation 1, equation 2. And now, get what you're looking for. So, let me say solution. We have this equation 3x plus 2y equals to 10. X plus 2y equals to 2. We want to solve this using substitution method. Remember what I told you? You can use x to make subject formula. You can use equation 1, but you always go to the, look at this one, x is standing alone here. So no need to go to those ones. Even if you use one, you still have the same answer. But so long as this one is standing alone, it's easy for you to do what? For you to substitute. So what you now do is that you now say from, this was called this equation 1, call this equation 2. So from equation 2, I can make a subject formula here, yes. So that x will now be what? 2 minus 2y. You understand? So when you now get that, we can call that equation 3. Please look up. I have been able to use equation 2 to substitute to make x subject formula. So I will not substitute there again, rather I will go to equation what? Is that clear? Yes, so I now say put equation 3 into equation what? 1. So I now put equation 3 into equation 1. This equation 1, 3x plus 2 y equals to 10. That was equation 1. So I want to substitute this x in this place. Have you seen that? Yes. Where I see x, I substitute that. So that place will now be 3 into 2 minus 2y plus 2y equals to 10. Is that right? Then we expand this. What is the value of 3 times 2? Is that? That would be 6 minus 3 times is what? 6y. So this place will now be minus 6y plus 2y equals to 10. Is that right? Yes, sir. So therefore, this value, we see that immediately we substitute the value of x into that point. We don't see y again. Y has disappeared. Have you observed? Yes, sir. Because x that we make subject formula here has now replaced the value of x here. Because this value we have here, we now copy and paste. So that place becomes 2 minus 2y. So at that point, we can now expand 3 times with this, 3 times with this. So this now look alike. You don't have x again. You see that with this method, we can eliminate x. If we make x subject formula, we now use it to find y. If we make y subject formula, we can use it to find what? X. So from that point, this is going to be, we collect like them, 6 will cross over. So minus 6y plus 2y will now be 10 minus 6. So minus 6 plus 2, that will be minus 4y. 10 minus is what? 4. So multiplying through by minus, dividing through by minus 4. Y will now be what? 4 over minus 4. Abi? So y will give us what? Minus 1. When we get the value of y, you see we can get x. You can get x here. Is that correct? Yes. Are you following me? Yes, sir. So this place will now be you can now say put y equals to minus 1 into equation what? 3. Abi? So, what do we have there? X will now be equals to 2 minus 2 into y. What is y? Minus 1. I've substituted the value of y there. Is that correct? Yes, sir. So therefore my x will now be 2. This minus will multiply minus 1. Plus 2. So therefore x will now be, what is 2 plus 2? So therefore x equals to 4 and y equals to minus 1. I hope it's beautiful. Yes. So let's see example 2. Example 2 of substitution method. When is time, you do that. You have time. So for substitution method, we have example 2. Example 2. The question is, you should solve the equations. Solve the equations 4x minus 3y equals 11, 2x plus 5y, 2x plus 5y equals to 25. And you're asked to solve that. If you see this one does not have one that is staying alone, So you cannot run away from it. You still have to solve it. Eh? So we now say solution. Because mathematics must have a solution. So the solution we have here will be, we call this 4x minus 3y equals 11. I call this equation 1. 2x plus 5y equals 25. I call this equation 2. So from equation 1, look at that. From equation 1, four x minus 3y equals 11. We can make x object formula here. We can make y. Maybe? So 4x equals 11 plus 3y when it cross over. Is that correct? Yes. So therefore 4x, we can make x object formula now. Dividing through by 4. Maybe? Yes. X will now be what? 11 plus 3y all over 4. If we call this equation 3, we use equation 1 to get 3. So you cannot put it inside equation 1 again. If you put it there, you return back to the original equation. So what we now do is that we now say put equation 3 into equation what? 2. You see what I'm doing there? I put it into equation 2 and I'm going to get this is my equation 2. You can bring it out. What's equation 2? 2x plus 5y equals to 25. That was equation 2. So we will substitute the value of x. Look at this x here. Look up. This x. I bring this to that point. Have you seen that? Yes, sir. So this place will now be 2 into 11 plus 3y over 4. Close the bracket. This 2 is here. Plus what? Equals to 25. Recall that what we do here, we've solved questions like this in a linear equation. So in a case like this, we have to find the LCM. We can even use this one, the concept to have to simplify it. Before we proceed, it's still the same thing. So from that level, this, cancel the 7, cancel how many times? So we have 11 over what? 3y all over 2 plus 5y equals to, I'm simplifying it. But even if you stand here and say multiply 1 through by 4, so you have the same thing. So since I have divided, what am I going to multiply through now? Because the LCM is now 2. That's how mathematics is. From the one you know, it helps to do the other one. So from that point, what we now have there will now be multiplying through by 2. So let's multiply through by 2 and see what will happen. Multiplying multiplying 2 by 2. This will now be 2 times 11 plus 3y over 2 plus 2 times 5 equals to what? 25 times 2. Abi? We multiply all through by 2. When we do that, 2 will cancel out 2. Is that true? What do we have left? 11 plus 3y. What's 2 times 5? 25 times 2. So from there we can now collect like terms. This place was plus. So 11 plus 3y plus 10. We can collect this 11 to the rest that we have. Collect like terms. 3y plus 10y equals to what? 15 minus 11. So 3y plus 10 is what? That will be 13y equals to 50 minus 11. 39, Abi? So what happened there? Y will now be what? 39 over 13. So how many 13 do we have in 39? So y equals to 3. So immediately we get y to be 3, we can get x. Look at this without wasting time. Look at x. Eh? So what do we do there? Just substitute 3 here. Abi? You can get y. So therefore you now say put what? Y equals to 3 into equation what? So this place will now be x equals to what? 11 plus 3. What is y? Divided by 4. I have substituted the value of y that I have there. Remember what I told you? Make any first subject of what? Formula. Subject of equation. Now substitute it in the other one to get the rest. So therefore my x will now be 3 times 3 is what? 11 plus 9. Eh? That will be 20 over 4. And the answer equals to what? So x equals to 5. Y says beautiful. So that is that. So let's see how we can solve example 3. Example 3. Example 3. Three x plus 4y equals to minus 6. Solve. 5x plus 6y equals to minus 8. Let's see how we can solve this. Solution. After this, we are going to go to the 3 by 3 variables. We have x, y, z. How do we do that? 3 unknown. So from here, we have 3x plus 4y equals to minus 6. Call this equation 1. 5x plus 6y equals to minus 8. Equation 2. Now, either you want to use equation 1 or you want to use equation 2, you still have the same answer. So from equation 1, 3x plus 4y equals to minus 6. I want to make x subject formula there. But I've been using equation 1. Let me use equation 2 this time. Abi? Say like 1. You are addicted to 1. So therefore this place will now be, let me make x subject formula there. 3x equals to minus 6 minus 4y. Abi? So therefore x will now be what? Is that correct? I call this equation 3. So I put 3 into 2. Are you with me? This equation 2, let me bring it out. 5x plus 6y equals to minus 8. So whenever I see x, I copy and so this place will now be 5 into what is the value of x? Minus 6 over 3 plus what? Equals to minus 8. Are you following me? So, now, the coefficient of x here is what? The coefficient of x is, the value, the LCM of this is 3. So you can multiply all through by 3. Have you? So now say, multiplying through by 3. If you multiply through by 3, you are going to have 3 times 5 into minus is minus 4y over 3 plus 3 times what? Equals to minus 8 times 3. Are you there? Yes. So this cancel out this. Abi? So we can bring out the corresponding value that's remaining. Which will have 5 times minus is what? Minus 30 minus 20y. Are you following me? Yes, sir. Plus 18 what? Equals to minus 20. Is that correct? Yes, sir. Immediately you finish from this place, the game is over. So this place will now give us minus 20y plus 18y equals to minus 24 plus 30 because it has crosses. A minus will turn to what? Plus. So minus 20 plus 18 minus 2y. Minus 24 plus 30. That will be 6. So dividing through by minus 2, y will now be 6 over minus 2. So y will now be what? Minus 3. So we get y to be minus 3. We now substitute here in equation 3 to get x. So now say put what? Into equation 3. Look at equation 3 here. X equals to what? Minus 4 into, what is my value of y? Over what? That will be minus 6 plus. Are you following me? Yes, sir. So 12 minus 6 is what? Abi? So it says, it cancels how many times? So you can see that x equals to what? 2. And what? Y equals to. We've been able to get that. Are you following? Yes, sir. So let's go to solution of unknown in a system of 3 linear equations. But that one is always very nice. Sometimes some people don't understand, but it's very sweet. If you know the rule, you can do it well. So, solution of unknown in a system of 3 linear equations. Solution of the unknown in a system of 3 linear equations. Let's say example 1. Linear equation of 3, that is x, y, z, a, b, c. The last one we've just finished is what? x, y, a, b. Have we? So now, if they say solve for x, y, z, solve for x, y, z in the equation, you need to be very interested in this question because there are some rules involved. What is 7? That's the question. We want to solve for x, y, z. We can use elimination method. We can use substitution method. I'm going to use the 2 for this. Let's start with elimination method. We all know how to eliminate. But in this case, we have 3. This is just like a football tournament. We have 3 teams. So you marry them in such a way that, look at this. You take this first 2. Take the last 2. First 2, last 2. For the first 2, we have 2x. This is z. Plus 2z. This minus z. So, for equation 1, you have 2x plus 3y plus z equals to minus 1. X minus y plus 2z equals to 7. We take the first 2. That is taking the first 2 equations. Taking the first two equations. That's what you get. Now, this one will wait. Take the first 2. Then from there, now take the last 2. For the first 2, you see that we can make x to be the same. Have you? You can say, if this is equation 1, this is my solution. I call this equation 1. 2x plus 3y plus z equals to minus 1 was equation 1. X minus y plus 2z 3x y. So we take the first 2 equations. Now when they take the first 2 equations, we try to make it to be the same. So you now say equation 1 times what? One, 2. That is multiply what you have it with here and this with here. So this place will now be 2x plus 3y plus z equals to minus 1 equals to 1. Then multiply 2 times what do you have? 2x minus what? 2y. What's 2 times 2? 4. Equals to 14. Equation 2. We remove x here. This and this is gone. You know that minus is what? Plus. So 3 plus 2 is what? 5y. This is 1. So z minus 4 minus 3z equals to minus 1 minus 14 minus 15. We can call this A. If you observe critically, you can see that when I match equation 1 and 2, I have successfully eliminated x. Have you seen that? There's no x there anymore. So it's remaining 2 variables, x, y, and z. So I now also go to the last 3, this and this, which is what? I have finished with this one. I have finished with this. So I want to use with this. You can see that the value of the second equation is lying as intermediate between the two, just like a neutral line. So you use this one with this one, you get this. Use the same middle point with this one to get the next value. So when you bring this out, taking the last two what? The last two is now what? X minus y plus what? Equals to 7. What is this one? 3x plus 2y equals to so since we've been able to eliminate x here, we also have to eliminate x in this one. So this place will now be equals to this was equation 2, equation 3. So equation 2 times what? Equation 3 times what? So multiplying 3, what do you have? 3x minus 3y plus what? 6z. What's 7 times 3? 1 times all that is the same. So that place will now be what? 3x plus what? Minus z equals to, they now look alike. Abi? You can call this whatever equation you like. But you see that if you subtract this from this, it's gone. Abi? If I was calling this equation 1 and 2, this one was equation 3 and 4. So when I multiply, I have, if I was calling this 1, 2, 3, I call this 4, 5. I can call this 6 and 7. So they look alike. Okay? So this and this is gone. Minus 3 minus 2 is what? Minus 5. Why? Minus minus is plus. Is that correct? So 6 plus 1, 7. That's 6z plus z is what? Plus 7z. 21 minus 1. So you see, that place is minus 5y plus 7z equals to 20. That is equation B. I call this A, I call this B. It is just like a game where you have x, y, z in the starting point. So in the first round, you can agree with me that x is nowhere to be found in equation A. Have you? And x is nowhere to be found in equation B. So you can now bring, they have finished the first round, so we are going to bring these two out to get to the second round. Is that right? So when I bring this out, I'm going to have 5y minus 3z equals to minus 15. That was equation this. Now, minus 5y plus 7z equals to 20. What are we doing here? We are taking the last two equations, which is what? A and B. Are you following me? Yes, so you want to solve that. So in this case now, since we are still using elimination method, unknown of that method, we can now find the value. Look at this, you have 5y, you have minus 5y. It's not all that you subtract. At this point, you can also add. Whatever you can make it to eliminate. Are you getting me? Because if you subtract, minus minus will make it to still be bigger, which is 10. Abi? Yes. But if you do what? If you add, you now say equation A plus equation B. Let's add. 5 plus 1 is what? 10. Abi? Minus 3 minus 7. If you add, sorry, I was explaining that if you subtract, that is, if you subtract, it's adding. But if you add, it's gone. Abi? So if you add this, 5y plus minus, 5 minus 5 is gone. So this one is gone. Is that true? Then minus, this was minus 3z. So minus 3 minus 3 plus 7. It's just like saying 7 plus 7 minus 3, abi? That will be 4z. Is that correct? Equals to minus 15 minus, no, minus 15 plus 20. It's the same thing as saying 20 minus 15, abi? The answer is what? 5. Is that true? So from there you divide through by 4. If you divide through by 4, my z will now be what? 5 over 4. That will be 1.25. We've gotten the value of z. So you can use either equation A or B to get y. Is that correct? So we can then say substituting what? Equals to 1.5 into equation what? A. Whenever I see z, I put 1.25. Is that clear? Yes, sir. So this place will now be 5y minus 3 into, what is the value of z? 1.25 equals to what? So 5y multiply minus 3 with 1.25. Minus 3.75 equals to minus 15. So therefore 5y will now be minus 15 plus, what one will cross, have we? 3.75. So my 5y will now be minus 15 plus 3.75, 11.25. So therefore my y will now be minus 11.25 all over 5. What will be the answer? Minus 2.25. So we have gotten the value of z, we've gotten the value of y. We can get x. In this time we are using either equation 1 or equation 2 or equation 3. Abi? So let's see what will happen there. We now go back to equation 1 or 2. We can use 2. 2 is easy because x is standing alone. Abi? So let's see. We say from equation what? 2. What is happening there? X minus y plus 2z equals to what? Equals to 7, have you? So you now say put y equals to minus 2.25. Have you? What else? Z equals to what? 1.25. For, what are we looking for? For x. So therefore my x minus into minus 2.25 plus 2 into, what is the value of z? 1.25 equals to 7. So therefore x, what's minus minus? Multiply this with what do you have? Huh? That would be 2.5 equals to 7. So therefore x, if you add this, that is what you have. 2.25 plus 2.5. That will be plus 4.75 equals to 7. So therefore x will now be what? 7 minus 4.75. That gives us x to be what? 2.25. So that will be 2.25. So you can now conclude there that x equals to 2.25, y equals to what? Minus 2.25, and z equals to what? 1.25. That's the business. I hope it's beautiful. This is the kind of mathematics I like. Huh? Huh? Yeah. So that's how we apply elimination method. So you can see this question and you in substitution method. That's method 2, substitution. So let's go to substitution. Still in the same question. Method 2. Substitution. Two x plus 3y plus z equals to minus 1. X minus y plus 2z equals to 7. 3x plus 2y minus z equals to 1. This was equation 1. This method 2. So for substitution method, we can use any of those values. You remember how substitution is? You make one expression subject of formula. Have you? Yes, you substitute in others. In this case, if you make x subject formula here, you put it in the 2. Have you? Yes, but I want to use equation 1 because x is standing alone to make the job easy. Even if you use equation 2, you still get the same answer. But in math, when you see the simplest way, just follow that track. It will make it easy for you. If God opened way for you in math, shortcut you can use. You now want to use the hardest. So, I want to use this one as an example to you. But before that, if you have any question, you are free. This interactive session. Yes. Okay. Yes, we can use a echelon method. But in this one, we are using linear, we are using a substitution method. Are you getting me? So when we get to that level, we are going to do that. Any question with respect to this? Yeah.
So what if we are using the last two first?
The last.
The last two to solve.
Okay. If you use the last two to solve, there's no problem. You see get, you understand? Now, even if you want to use this one as a reference point, use this with this, and use this with this, you still get the same answer. Are you getting me? But one must be as in, just like electrical wiring, one must be neutral. So that if you have 3 lines, 1, 2, 3, you use this one and tap with this. Use this one and tap with this. If you don't want to use this middle one, you can use this one with this. Say use this one with this. And how you want to use it, it's the same answer that you're going to get. Is that clear? Any other question? Any other question? This is interactive time. So you're free to ask questions. You're free to ask questions. All right. Now, let's get into this substitution method. Like I was saying, you have to use one. We have three equations here. One has to die for the two to survive. So in that case, one equation 2, immediately equation 2, you make x equation 2. We don't need it again. Instead, we substitute it in equation 1 and equation 3. That is to say that equation 2 has become the sacrificial lamb for others. Are you following me? Yes, so from solution of that equation, solution, that marker is not bright. Let me use for something brighter. Brightest. So, in solution we have, please look at this. I call it from equation 2. From equation 2, x minus y plus 2z equals to 7. I make x subject of formula there. Abi? So x will now be what? 7 plus y minus what? 2z. If I call that equation 4, you see, one has been able to be used to make a subject formula. So we are going to use it to substitute not in equation 2 again, but rather in equation what? 1 and 3 respectively. Are you getting me? So from that point we have, you can now say put equation 4 into what? Equation 3 and you can see equation 1 and 3. Because this is the one that is used to sacrifice to get x. Are you following me? So for equation 1 we have 2 into wherever we see x, we put this value. 2 into what? 7 plus y minus 2z. Are you with me? Yes, plus what? 3y plus z equals to minus 1. So with this, we can open that bracket. Have you? Yes, so 2 times 7 is what? 2 times y. 2 times minus 2. 3, this is what? Is that right? So we can collect like terms now. Y goes to y. So this will be 2y plus what? 3y. What else? Minus 4z plus z. Abi? What do we have next? This and this goes here. Equals to minus 1 minus 14. So you see that 2 plus 3 is what? 5y minus 4 plus z minus 3z equals to minus 1 minus 14. You can call this A or whatever alphabet. If you observe, when we're solving the other one, this is what we had in the first instance. I mean? So what do we go there? We now have to, we have been able to put in equation 1. I mean? So you have to also put in equation not 2. 2 was the sacrificial lamb. So you put it in equation 3. So when you put it in equation 3, this place will now be Put in equation 3, that will now be equals to what? Put 4. Okay, let me say for 4. Where's equation 4? Or for 3? This is 3. So I will have 3 into what is x? 7 plus y minus 2z. We have been able to put in that place. Look at this plan I'm talking about. Wherever I see x. Have you seen that? So we put that 3 plus that. Plus what? 2y minus z equals to, we now multiply that 3 out. If you multiply the 3 out, 3 times 7 is what? 3 times y minus what? Plus 2y minus z equals to 1. So you collect like terms, have you? 3y plus minus 6z minus equals to 1. Is that right? Yes, sir. So 2y plus 3y plus 2y. So that place becomes 5y minus what? 7z, Abi? 1 minus 21. Eh? Minus 20. That is B. The difference is that the other one minus was here, another one was plus. But the same thing. So you can now bring them together. From equation 1, from equation A, we can make y subject formula because we are talking about substitution method here. So everything we are going to do is what? Substitution method. Abi? So this place will now be from A, 5y minus 3z equals to minus 15. 5y will now be what? Minus 15 plus 3z. Have you seen that? Yes, sir. Minus 15 plus 3z. So 5y will now be minus 15 plus 3. We can make y subject formula here. Y will now be what? Minus 15 plus 3z all over. So we have used this equation to get this. So we are going to substitute this into the second one. Right? Yes, sir. So this is, I can call this C. So now I say put C. Put C. So you now put what? C into where? Huh? Look at that. We have two equations that we've been able to get. This one and this one. But we use this to get this. So this one is now left. So you have to put it wherever we see y there. Are we together? So that place will now be 5. So now put C into B. This place was B. So 5 into what is my y? Minus 15 plus 3z over 5. What else? Minus 7z equals to minus 20. So this cancel out this, have we? So you now have what? Minus 15 3z minus 7 equals to minus 20. So from here you collect like terms. So 3z minus 7z equals to minus 20 plus 15 when the minus cross. Okay? So 3 minus 7 is what? Minus 20 plus 15. That will be minus 5. So minus cancel out minus. So z will now be what? 5 over 4. Which is what? 1.25. We've been able to get the value of z. So we can use c to get y. Is that possible? Yes, sir. So you now say put z equal to 1.25 into c. For what? For y. Want to get y. So therefore my y will now be what? Minus 15 plus 3 into 1.25 divided by 5. Have you seen that? Wherever I see the value of z, look at it here, this one, this place. So that value there. So that will now give us y equals to minus 15. That will now be minus 15 plus 3.75 is what? Minus 11.25 over 5, right? So minus 11.25 over 5 is what? 2.25. There's a minus there. So my y is minus 2.25. So with this 4, with this equation 4, we can get x. Is that right? Yes. So from equation 4, x will now be 7 plus minus 2.25 minus 2 into what is it? You got Z there. 1.25. So therefore my x will now be 7 minus 2.25 minus 2 times 1.25 is what? 2.5. So solve that. 7 minus 2.25 minus 2.5. The answer will now be 2.25. So you can now summarize by saying that x equals to 2.25, y equals to what? Minus 2.25, and z equals to 1.25. That is the answer. I hope we had the same answer with when we are using that's beautiful. So if you've been able to solve that 3 by 3 easily. So let's see how we can go into word problems leading to simultaneous equation. Word problem leading to simultaneous equation. So we can transform words problem to solve simultaneous equation. Then we find the value of the unknown quantities. They give you a word problem. It's very easy for you to turn it to simultaneous equation. Now from there you find the value of the unknown. Let's see how we can solve example of that. Word problems leading to simultaneous equation. Leading to equation. Just like I said that when I give you a word problem, you can transform it to simultaneous equation. Let's see how we can do that. Example 1. The sum of two numbers. The sum of two numbers is 14 and their difference is 2. Find the numbers. The sum of two numbers is 14 and their difference is 2. Find the numbers. Remember what I told you when I gave you a word problem? You need to get the number to represent what? Alphabet, have you? So if we say the numbers are x and y, solution. What do we say? Eh? Let the what? Let the numbers be x and y. I hope you're learning. The number we're talking about, let it be x and y. So let's go back to the given question. What was the given question? The sum of two numbers is 14. Abi? You can do that. Sum of x and y, Abi, equals to what? That is x plus y equals to 14. Is that true? And their difference is 2. Their difference is 2. Difference of x and y. What is difference? X minus y equals to what? Do you see the way the question comes out? Has it not done simultaneous equation? Yeah, Kabasem. It has. So, we've been able to establish a simultaneous equation. So, x plus y equals to 14, equation 1. Abi? Yes, sir. What else? So from that point, we've been able to establish a fact there that we can find x and y simultaneously. Whether we use elimination method or what? Substitution method. Have you? So which one is preferable? Any one. So we can just say equation 1 minus 2. Abi? We can subtract, x is gone. If we say equation 1 plus 2, x will remain. Abi? This one is stay. Abi? So if you subtract, This is gone. Y minus what? Plus. That is 2y. 14 minus 2. So therefore, dividing through by 2. Y is what? 12 over 2. What is the answer of y? 6. So you can use either equation 1, equation 2 to get x. So from equation 1, x plus, put y there. Abi? So x will now be what? 14 minus 6. 14 minus 6 is what? So x equals to 8. Y equals to what? See how we can solve that word problem easily. Let's see how we can solve. So you now see that the two numbers are 8 and 6. So, if you're given something different from this, but still what problem? They say if 2 is added to a numerator and denominator, it becomes 9 and 10. And if 3 is subtracted from the numerator, it becomes 4 over 5. Find the fraction. I think I love this particular question. It's nice. And you can do that. That would be example 2. That would be example 2. If 2 is added to the numerator and denominator, it becomes 9 over 10. And if 3 is subtracted from the numerator, it becomes 4 over 5. Find the fraction. Find the fraction. Find the fraction. Now let's see. The fraction we are talking about here will be, you know what fraction is now? Numerator and denominator. So if you say the numerator be x and denominator be what? Y. So the fraction will now be what? X over y. Abi? So what do? We now say, let the fraction solution. Let the fraction be x over y. So if the fraction is x over y, we are going to see how you can solve that math. It's a very nice question. Abi? Very nice question. Questions are prepared for this project. It's very technical and calculated question that you can stand the test of time. Praise the Lord. Hallelujah. So it's not a given. Let's go back to that question. If 2 is added to the numerator and denominator, it becomes 9/10. Now we call the fraction x over y, abi? Yes. Now the statement says, if 2 is added, so given, if 2 is added to what? Numerator and denominator. What did I say is the result? It becomes 9/10. What does it mean? It means that if we add 2 to x plus 2, abi? Over what? The answer will give us 9/10. Is that true? Yes. Huh? Yes. With this, we can cross multiply. So this is 10 into x plus 2, 9 into y plus 2. So multiply this. 10x plus 20 equals to 9y plus what? Is that right? Yes, sir. So if you connect this to this, you have what? 10x minus what? Equals to 18 minus or? Is that right? So we have 10x minus 9y equals to 18 minus 20 is what? Minus 2. You got that guy equation 1. Is that right? Then the next topic, the next point in that question is, and if 3 is subtracted from the numerator, if 3 is subtracted from the numerator, let's put it down here, and denominator. And denominator, both that is up and down. It becomes 4/5. So if it's subtracted from both, so in that case, what do we do? Subtraction now. Huh? If 3 is subtracted from what? Both numerator and what? Denominator. They say it becomes what? So you can present that one, abi? That is to say we subtract if we subtract this, what we are having. From the original expression, we subtract 3. That is x minus 3 all over what? What's the result? Can we cross multiply? Yes, sir. That will be 5 into x minus 3 equals to 4 into what? Is that right? Yes, sir. So you expand this, you have what? Equals to what? So you arrange to have 5x minus what? Equals to minus 12 plus what? So 5x minus 4y equals to minus 12 plus 15 is what? 3. Call that guy equation. So we have, if you bring equation 1 and equation 2, he has formed simultaneously. So we now bring, what do you say? It's fun, man. 10x minus 9y equals to minus 2. We bring the two equations together. That was my equation 1. 5x minus 4y equals to 3. You can solve that either with elimination method or substitution method. So let's see what will happen there. Let me show another version of solving this without multiplying equation 1 and 2 and equation 1 and 2. Look at this. If you have this place is 10, you can make this place to be 10 without saying 5 times 10, 10 times 5. Is that true? If you multiply equation 2 by 2, what is 5 times 2? 10. So this place automatically be turned to 10. We can now subtract. But you don't only multiply here, you multiply with all. Do you understand what I mean? Yes, so you now say multiply multiplying equation what? 2 by 2. So this place will now be what? 5 times 2 is what? 10. So we can rewrite this thing to make it easy. You can say 10x minus 9y equals to minus 2. Then 10x minus, I'm just multiplying. My equation 1 is still there. I just multiply equation 2 by 2. So 5 times this is what? 10. Minus what? 8y equals to what? 6. Abi? From here you can subtract easily. Have you seen the arrangement? So from there, 10 minus 10 is gone. Minus minus is what? Plus. So minus 9 plus 8. That will be minus y equals to minus 2 minus 6. That will be what? Minus 8. So therefore, from here, multiplying through by minus, you can say minus cancel out minus. Y equals to what? 8. So since we are putting the value of y, we can put it in anywhere. Even if you stand here, you can get x. You stand here, you can get x. You can stand any place. So long as you get y, x is bonus. So you can just say from equation 1 here, 10x minus 10 into x minus 9 into what is y? 8 equals to minus 2. So 10x minus 9 times 8. 72, that place becomes 72 equals to minus 2. So 10x equals to minus 2 plus 72. Okay? 10x will now be, what is minus 2 plus 72? That will be 70. Okay? So multiplying through by, dividing through by 10. X will now be what? 70 over 10. What's the answer? 7. So in that case, x equals to 7. So therefore, x over y will now be what? 7 over what? 7 over 8. That's the answer. So, if you put 7 here, what is 7 plus 2? 9. Huh? 9. If you put, what is y? 8. What is 8 plus 2? 10. So that is the business. That's the beauty of mathematics. So, we are going to see how we can disgrace mathematics in different ways. We are just starting. So, that is taking one molecule of water. That is H2O. Everything is mathematics. Hope you like this particular question.
Yes, sir.
Okay. Now let's see another complicated one before we go into quadratic equation. All right. That was example 2. Example 3. If twice the age of son is added to age of father, the sum is 56. But if twice the age of father is added to the age of son, the sum is 82. Find the age of father and son. If twice the age of son is added to the age of father, the sum is 56. But if twice the age of the father is added to the age of son, the sum is 82. Find the age of father and son. Just like the way we've done before, we have to assign an alphabet to those numerical values, right? So, solution. We use the father's age to be x. Abi? So, someone should use A and B. So let the father's age, any alphabets, be A. Abi? And it's going to be A years. And the son, the son's age be what? Be Y years. Y years. Now let's go back to the question. Let's see the question. Okay. Now, let the father's age be X, abi? Or be A, and the son age be, let me use A and B. Abi? Now, they say, if twice the age of son, twice the age of son, abi? Let's talk about twice the age of son first. Twice the age of son will be what? 2A, abi? Twice the age of son. We do it step by step. Now, twice the age of son added to father's age. Look up. If twice the age of son is added to the age of father, so twice the age of son added to the father's age will be what? Twice the age of son plus father. Father's age, I mean? Now be what? 2B plus. Is that correct? Yes, sir. Now what's the next statement? If twice the age of son is added to the age of father, the sum is what? Have you seen what is happening there? So therefore 2b plus a equals to what? See how mathematics is. If you follow it step by step, the game is over. Now, the next statement. But we have finished this one now. We form equation 1. Have you observed? Yes, sir. Now what's the next statement? But if twice the age of father is added to the age of son, what is twice the age of father? Twice the age. Father is what? A. So twice the age of father equals to 2a. Maybe? Added to the son's age. Added to the son's age. That will be what? 2a plus what? B. The sum is 82, Abi? There's two value here. 2a plus b equals to what? That's question 2. Now, you see that the give two simultaneous, Abi? It gives two simultaneous equations. So from there we bring them out. 2b equals to 56. 2a equation 1, equation 2. So from that level we can now solve this simultaneously. We can multiply equation 1 times what? These are not the same. This b, we can shift here. We will shift here, we now do the same, it's still the same thing. We bring a here, bring 2 here. So this is just like saying 2b plus a. You can write a before b. You can say a plus 2b, maybe, equals to 56. And what? What else? 2a plus b equals to 82. So we can now multiply equation 1 by 2. Equation 2 by what? 1. If I leave you at this point, you can solve it very well. So, from this point, we now say equation 1 times 2, equation 2 times 1. So 2 times a, 2a plus 4b. Why 56 times 2? 112. Now 1 times, that is just a copy and paste. 2a plus b equals to 82. So from that level, we subtract. This is gone. Now 4b minus b. 3b. 112 minus 82. Eh? That's 30. This is 0, 3. Now dividing through by 3. B will now be 30 over 3. So b equals to what? 10. So you get b equals to 10. We can use either equation A, equation 1, equation 2 to get A. So you can say from equation 1, when equation 1 happened, 2b plus a, or you can say a plus 2b equals to what? So therefore, A plus 2 into, put B there. 10. What do you put there, 10? Yes. So A plus 2 times what? A will now be what? So in that case, the father's age is, the father's age is what now? What was A? A was standing for what? And so therefore the father's age equals to 86, and son's age equals to what? 10. That is that. So we've been able to solve a simultaneous equation that is derived from word problem. So you can tackle any question that comes our way, so long as this particular one is concerned. So let's go to quadratic equation. Quadratic equation. Under quadratic equation, we have some good questions to solve. But first, we need to understand quadratic equation. It's a topic that is very important in all mathematics topic. Quadratic equation. You can see quadratic equation. Quadratic equation in X. You see, quadratic equation is written in the general form ax squared plus bx plus c equals to 0. That's the general form of quadratic equation, where a, b, and c are real numbers. Are real numbers with a not equals to 0. That is quadratic equation. It is a second degree polynomial equation, because at this point you see that the power of x is 2. And we are going to see how we can talk about different ways of solving quadratic equation. We can use factorization method. We can complete the square method. We can use even calculator. We have so many ways of solving quadratic equation. Graphical method is much. So we are going to treat them one after the other. One after the other. So the first method here is factorization method. You see, if you have a product of two linear expressions, this is a linear expression x plus a. Have another equation like x plus b. These are linear equations, have we? Yes, so it's a product of two linear equations. So if we expand this, let's expand it and see what will happen. X plus a, then x plus b. Let's expand this. What is x times x? X times this, bx. A times x, a times b, ab. You can agree with me that in that expression, that the coefficient of x, if you observe there's a common factor here, abi? This place can be x squared plus what? B plus A into x plus AB. So x is common between these two, you take it out. Abi? So the coefficient of x, what's the coefficient of x in that expression? The coefficient of x is b plus a. So now say the coefficient of x is what? B plus a. And now the constant, what is the constant? The constant equals to ab, and this one is b plus a. Now if you come to look at those right up, you see that in quadratic equation, we are looking for two factors. In factorization, we are talking about factorization here. Factorization. Factorization method. So in factorization method from this expression, we are looking for two factors. So that when we add, we have this place. And when we multiply, we have this place. That is how we factorize. So let's talk about factorizing the quadratic expression with the coefficient of x squared. Coefficient of x squared. Let's see. Example 1. Example 1. Please, everybody stand up. Everybody stand up. Everybody. All right. Sit down. To say that you stress yourself. It's part of the job. Now example 1 says, factorize x squared plus 6x plus 8. Factorize that. That is, factorization means express this in two linear form. Are you getting me? Express it this way. That is the meaning of the word factorize. So, what we do there is that I want to show you the steps on how to factorize. Because you are going to express that in two linear forms. You are going to look for two factors. When you add, you have this place. When you multiply, you get this. So let me give you the steps on how to factorize. The first step is to look for the factors of 8. Factors of 8. When you multiply, you have 8. And when you add, you have 6. Are you following me? Yes, sir. Now let's see how it goes. If you have factors of 8, what are the factors of 8? 1 times 8 equals to 8. Abi? Which other factor? 2 times 4 equals to what? Another one? It's the same thing as 2 times 4. So we are looking for 2 factors. When we multiply, we have this. When we add, so you can agree with me that if you multiply, you have 8 years. But if you add, you can never have 6. So this one is offside. Have you seen what I'm showing you? Because in some cases, you may have difficulties in factors. But if you bring those factors out like this, it will really help you. This one is easy, but the ones that are complicated. Are you following me? Yes, sir. So if you have this 2 times 4 is 8. 2 plus 4 is 6. So this is the factor we are talking about. So in that case, when you have those 2 factors, what we now do is that we link up to the value of x, because the factors of 8 equals to 2 and 4. So the factors are 2x and what? 4x. Because if you multiply 2x times 2x, you're going to have 8x squared. If you add 2x plus 4x, you have what? 6x. So if you now get those factors, what you now do is that you remove this and replace this 2 in that place. Are you getting me? So that place will now be what? X squared plus 2x plus 4x. 8 will still be there. Don't forget that we were factorizing x squared plus 6x plus 8. And now, when we get to this step, we now bracket it. We group them. When we group them, you see that in the first bracket, something is common. I mean, what is common there? So you now take x out. What is now left here? Someone will think that if you remove x here, that square will be on top. Eh? It's not like that. Because x squared means x times x. Are you learning? Yes, so when I take x out, x will now remain there. Plus, I have removed x out. What's now left here? So in this second bracket, what is common?